interactive session with the Rashtrotthana students and Dr. Somanath. A warm welcome to you, sir. I request Dr. Vineet Mohan to escort Dr. Somanath to the dais. A warm welcome to you, sir. Dr. Somanath, sir, does not need any formal introduction, but still, a brief introduction, a very, very brief introduction. Dr. Somanath, sir, is the Secretary of Department of Space, Chairman of ISRO, and an expert in space technology and launch vehicles and systems engineering. He is a mechanical engineering graduate with a master's in aerospace engineering and a doctorate from the prestigious Indian Institute of Science, Madras. He has led ISRO to numerous achievements, including Chandrayaan-3, Aditya L1, INSAT 3DS, GSAT, and many, many more. A recipient of multiple awards and honorary doctorate, he also serves as the Vice President of the International Astronautical Federation. Once again, a warm welcome to you, sir. We are very blessed to have you with us. We also have with us Dr. Sandeep Nair, who is going to moderate the session. I request Dr. Anirudh to escort Dr. Sandeep Nair to the dais. A brief introduction about Dr. Sandeep Nair. He is the Registrar of Evaluation, Chanakya University, and the Dean of School of Arts, Humanities, and Social Sciences. He has a rich 29 years experience in teaching, research, and consultancy. He is a member of the academic, social, student, and spiritual organizations, and is also the Rotary Cultural Ambassador to Germany. A warm welcome to you, sir.
Thank you.
I now hand over the mic to Dr. Sandeep Nair to this interactive session, which all of us are going to find it very exhilarating with a soft landing on the moon once again. Thank you, sir.
Thank you. I'll start here, then I'll go there. It's indeed an honor. Namaskaram to all. Respected Somanath sir is a pride of India, a proud citizen of India, and an inspiration to all of us. Respected teachers, students. This is not my time. This is perhaps a time for you to experience what inspiration is. I'll start with one question before you ask question to Somanath sir. Today is 4th January 2025. What's special today? Anybody can answer. Today is a very special day for us, but it's also a very special day for Earth, for the universe. What is special? Anybody? We should always, because we have connectivity to Google, try to find out. Today is a perihelion day. Today is the day when Earth is the closest to the sun. And what a coincidence. We are closest today to the man who took us to the moon. What a tremendous coincidence, and we are indeed fortunate. Now, I will not stand before you and your learning experience. There are a lot of questions which have come to us. Sir, these questions are amazing, from everything from science and technology to personal inspiration. So as I call out the name, the student may kindly rise and read out the question, and sir will answer this question. Are you ready? Are you ready? Wonderful. So, sir, presenting to you Chandu CM, Class 11 from Tapas. Tapas is a Rashtrotthana initiative training children for IIT admission. Chandu, you may read your question, please.
Namaste, sir.
Namaste.
Do you think the material being used at present for the outer covering of space shuttles are most efficient, or could it be improved? Is ISRO working on it?
Chandu, I think you are referring to the covering on the satellite or rockets?
Space shuttles.
Space shuttle. Ah, okay. So the space shuttle is the one which Americans used. You are talking about that?
Yes, sir.
Okay. I think space shuttle is no longer flying. You are aware of it. But we are making our own shuttle, reusable launch vehicle, RLV. So the material used on the outside, what you see, the black color, gray color, are high temperature ceramics. You know ceramics?
I don't know much.
Ceramics are the one you take lunch in a ceramic plate, no? Okay, porcelain, ceramics, they are the materials which are of that type. So you make it very less density, porous, but it will withstand very high temperature. Temperature is like 3000 degrees and nothing will happen to it. One side can be 3000, other side when you touch it also, you can touch with hand. So even that type of temperature difference it will have. So I have seen it space shuttle myself. Once I went to United States when space shuttle launching was going on, I was invited and I saw that. And they showed me the tile. You can put it inside an oven. And then one end can be 1000 and the other end you can actually your hand. So that's the quality of the material. But the issue with that type of material is it is very fragile. If you drop it, it will break. And you cannot fix it with screws because metal screws cannot be used. So you have to bond it with adhesives. Adhesives, Araldite, quick fix. So some similar adhesives you have to use. But they will fall off. During flight, they will fail. Possibly you would have seen in SpaceX launch. Some of you watched SpaceX launched. The Starliner launched. When it came back, there were a lot of tiles missing. In space shuttle also, tiles will be missing. So this is very dangerous. Because if the tile is missing, what will happen is when it's entering, very hot air will get inside and damage the I am not comfortable sitting there. No? I feel as if I am sitting inside a well. So better I see your face. Huh? So these type of materials are really very challenging, and we have a lot of research happening on it, and we are developing these materials. But there are a lot of new technologies also coming. Without even using this material, how to build rockets, how to prevent such tiles bonding. So there is a new material called very evaporative bonding. In the material you use stainless steel, but inside there will be a liquid which will be evaporating. And if you make it's called evaporative cooling. So such rockets are also being tried. Today we are trying to develop similar materials. There is another material called metals itself which can withstand up to very high temperatures instead of ceramics. So they can be welded, they can be riveted. So a lot of research is happening in that area. Okay? Are you satisfied with the answer? You want something more?
Yes, sir.
Okay.
Dhanyavad, sir.
Dhanyavad.
I heard sir yesterday speaking in a conclave, and sir mentioned something very important about what is knowledge in Indian tradition. Knowledge is not belief, knowledge is questioning. So we are very happy to know that this question indicate a lot of knowledge itself, your understanding. Thank you, sir. Presenting Sai Suhas from Jai Gopal Goradia Rashtrotthana Vidya Mandir. Sai Suhas is here.
Namaste, sir. Today my question is that I will be very obliged to know if you describe the journey of our nation to make India reach to the moon.
Okay, it's a very general question. When India started the space program, which year, 1960s. 1960s, Americans and Russians were trying to put their man on the moon, and they achieved it in 60s itself. At that time, India was doing what? Launching small rockets from Tumba. So you can compare that we had a gap of 60 years between Americans and India in building rockets and space technology when we started the program. So when you land on the moon in 2023, it implies that we were able to bridge this gap, the technological gap that existed between America and India substantially. Without bringing down the gap, it's not possible for us to go to moon and land on the moon. You know, India is the very first country we went and landed on the moon on the southern side of the moon. Now nobody has landed there yet. Though Americans and Russians have already landed on the moon many times, mostly in the equatorial region. In the equatorial area, it is much easier to land because the area is more flatter, the boulders are not there, the planning of the trajectory is better, there is sunlight most of the time. There is a lot of advantage in going to the equatorial region. But in the near to the pole, a lot of issues are there. There are a lot of boulders and, for example, deeper crevices. Then also sunlight is very less there because sun is seen at a very low elevation. You will not be able to generate power. And even landing there also the guidance program, the software which is used to make is much more complex. The injection condition to reach there is also difficult. So we overcame all difficulties and then landed on the moon. So it shows that we were able to bridge this gap. And this 60 years of gap bridging is not easy. You need to work on many technologies, building rockets ourselves. We have not launched Chandrayaan-3 using someone else's rocket. We launched using our own rocket. You know which is the rocket we used?
Yes, sir, GSL.
GSL Mark 3. I was a project director of that rocket. I was part of the designing of the rocket. And it took almost 12 years to design and develop the rocket, one of the biggest rocket using our own cryogenic technology. And the rocket itself weighs 450 tons. 450 tons, can you imagine how big it is going to be? How many elephants? I don't know. So there are so heavy rocket and it is actually putting only 4-ton satellite into orbit. So even building the technology, building the infrastructure, building the knowledge, that is a great journey that we have. And you know, all this was done using how much of money? We didn't take much money. Our budget for space program was very less. We take our money from the government grants. It is less than 1% of our national budget. Why I'm telling it is when America started sending man to the moon, they spent almost 30% of their gross domestic product at that point in time to build their capability. So you can understand we were able to do it at very low cost. So this journey is something that we must all be very proud of, and we can do that in many more areas, not only in space, in every area we must be able to replicate. Okay? Thank you.
Dhanyavad, sir.
Dhanyavad.
Thank you, sir. Children, I want you to understand the insights as well. It's not about landing on the way we are growing there, the way we are developing, and the world is learning from us in terms of how to go about it. We have Srihari Malagi from Standard 10th, Rashtrotthana Vidya Kendra Banashankari. That is Srihari Malagi.
Namaste, sir.
Namaste.
Being an aerospace enthusiast, may I know what are the key areas of focus in ISRO on R&D in the years to come?
Lot of areas, my dear. I think the area of interest in aerospace is so artificial intelligence and machine learning. I think this is so much used in our space design now. So we use AI for our design of the rocket. For example, the guidance algorithms are genetic models that we are using for machine learning models that we are using. We use AI for interpreting data. We use AI for understanding the health of the rocket and satellites. And even for docking purposes, we may use a little bit of AI also. So AI is very much there. We use advanced electronic systems, for example, development of processors, detectors, new devices in electronics is one area. We use on many areas in propulsion. For example, we have traditional propulsion, solid propulsion, liquid propulsion, cryogenic propulsion. We work on electric propulsion now. So use the sunlight, generate electricity power, and then develop thrusters. So we are going to launch our own electric propulsion thrusters in the coming satellites. We are developing quantum technologies. No, quantum you heard? You know quantum technologies?
Yes, sir.
You heard of quantum cryptography, quantum computing, quantum sensing. There are many domains coming up. What we are working on quantum communication. So when you do quantum communication, you can use, along with cryptography, we can use it to secure our communication channels. So we are going to develop a quantum communication satellite, which will send the quantum key distribution to secure all our mobile phone communication, data communication, etc. So nobody can actually sneak into it and then find out what is going to happen. So we are developing new sensors. Sensors are, we take images, pictures. So when you look at the earth, what are you seeing? You can see the land, you can see the trees, you can see the buildings, you can see the roads. And when you take a picture, normally we take the picture from satellite and bring it down to the computer and analyze. Suppose the satellite itself can identify this is a car, this is a building, this is a road, then it can extract that data alone and send it to the ground. So when you have such capability, that is more intelligence on board, you can apply artificial intelligence and then use it for change detection. For example, this is important for how the city is changing with time, how our borders are secure, is somebody sneaking in or coming in through the borders. Suppose it's a war situation, what type of mobilization is happening there, you can understand. So, you can apply artificial intelligence and then use it for change detection. For example, this is important for how the there is an AI working, I believe, here. Huh? Okay, I think the recording is replayed, so I think don't worry about it. So you can use such technologies on board. So then we developed a lot of materials, new materials. I mentioned about high temperature materials. We are working on new chemicals which will give high energy for fuel and propulsion. So like that, there are so many domains, chemistry domain, physics domain. We are finding what is the best route to reach Mars. Earlier people used to reach in spending some energy. So there are mathematical formulations which will allow you to reach very fast the new paths. We did it for Aditya L1. Lagrangian point injection we did using one of the fastest and shortest energy path to reach that place. So this is again another research going on. So there are plenty of such research. If I start talking about it, I can talk about next 2 hours on different domains that we are working on in advanced technology. Okay?
Yes, sir. Dhanyawad, sir.
Thank you, sir.
Thank you.
We have Ravish coming with a very contemporary concern. Ravish Bharadwaj from Rashtrotthana Banashankari. Ravish.
Namaste Somanath ji.
Namaste.
My question is, how does ISRO plan to address the issues of pollution due to rocket launches?
You are worried about the pollution that is caused by rocket launches. Of course, rockets do pollute because it contains fuel which is not that green, is it not? When you say fuel is green, the combustion products don't give rise to chemicals which are reactive, which doesn't contain components which are causing warming or causing damage to something. For example, if you use a cryogenic stage, the fuel used is hydrogen, the oxidizer is oxygen, and when they combine together, what you get?
H2O.
H2O, water. So it is very green. You cannot get a better material than water as the combustion product. So if you are able to use kerosene as a burning fuel, we still call it green because the combustion products contains mostly carbon dioxide only. Not very NOx is not there, acids are not there. So we call it more greener fuel than the one which you use otherwise. So we use in solid motors, the fuel used is aluminum powder. So when you burn aluminum powder, we produce aluminum oxide, which is a non-reactive oxide, but it's still a pollutant. It also produces a lot of hydrochloric acid. For every PSLE launch, the acid which is thrown into atmosphere is typically around 20 tons of hydrochloric acid is thrown out. So it's really pollutant, I must agree. But you compare with the pollution that is causing rest of the places. For example, the cars burning the petroleum products, the tons of fuel which is burned in automobiles is far greater than the fuel that you burn in rockets. So really in terms of pollution, rockets are not a big pollutant in terms of, but our effort is to bring more and more greener fuels like the cryogenics, semi-cryogenics. So ISRO is going to move from solid and polluting chemicals to more greener fuels. For example, methane, we are going to use as a fuel for future. So the methane combustion is carbon and hydrogen. It contains only carbon and hydrogen. So it will produce carbon dioxide and water. So it is generally we can treat it as more greener fuel. So, and similarly solid also there are greener fuels coming. We are conducting research on it. So future we will be able to use
there are fuels called ADN, etc., etc. And there is other fuel called hydrogen peroxide, which you want to use it in satellites. Even satellites use a very chemical polluting fuel. In upper atmosphere, we have such fuel. So we are trying to move to peroxide, hydrogen peroxide based fuels. So there is an effort going on. But issue is such fuels have lesser efficiency. So we need to worry about it, efficiency versus pollution. No, we need to balance all of that. Okay?
Dhanyavad ji.
Thank you, sir. I remember, sir, mentioning about it's not about engineering and innovation, it's about responsible engineering and innovation. On that note, we go to class 9 student Vaishnavi HR from Hagari Bommanadi.
Yes, Vaishnavi, yeah.
Namaste, Guruji.
Namaste.
Is space tourism viable and what are your views in particular?
Yeah, space tourism is very much viable. Only thing is you must have enough wealth to pay for it, ticket charge. It's very high. Today the space tourism is very, very costly. It was costly for anything that when you start, no? Earlier when the airline started flight, when the aircrafts came for the first time for the flight, the ticket charges would be very, very costly. Only rich people used to travel. Now your airlines, only rich people are traveling. You can also travel, isn't it? The ticket charge can be varying from 2,000, 3,000 rupees to and above. So it is possible for us to travel in airline because the number of aircraft increased and the number of flights increased and it is more democratized. So same way space tourism also, today it is very costly. And today it is more for fun. It is not for any particular usage. Space tourism is, people want to go to 100 kilometers. They want to just see the earth and then enjoy how the earth will look like from 100 kilometers. They want to tell, yeah, I have crossed the Kármán line and I am an astronaut today. For that, people are ready to pay 5-6 crores per ticket. 5-6 crores of rupees per ticket. It is very, very high cost. Because every rocket is very costly and operations are very costly. Today it is that type of price. But I believe it will come down when it becomes more democratic. And I want to tell you one more thing. Some people are working on rocket-based transportation. Suppose you want to travel from India to Australia or India to America. I am very sure in another 10 years, there will be some rocket which will take you from here to America. Now today the flight time is typically 10-12 hours from here. But once a rocket comes, you can travel to America in just 30 minutes. And most of the time will be spent in preparing you to travel. I think 3-4 hours you may prepare to travel, but travel time will be only half an hour. But that preparation time also will come down in due course of time and finally you will be able to travel in very short time. So at that time, all of us will be space travelers and space tourists. Okay, so today we need to start work on space tourism because it's going to have a future like this. Human, regular people, not astronauts, all of us will simply get into a rocket like with the normal shirt and pants and then tie up with it as you sit in a car with your belt and possibly a helmet with the breathing apparatus, etc. And in 30 minutes, you should be able to travel and reach the destination. Is it not a good idea? Yeah, definitely. I think we must work for it. India should also invest in creating space tourism concepts, though it may be costly to start with, but I am very sure we should be able to achieve space tourism. Okay?
Thank you, sir.
Thank you.
Sushant Prabhu, Tapar student Sushant Prabhu, please.
Sushant? Yeah.
Namaste.
Namaste.
I want to ask that is there any plan for ISRO to build a traveling telescope which can beat the record of James Webb?
Traveling telescope. That means a telescope in space?
Yes, sir.
We already have one. You don't know?
No, sir, I don't know.
Our telescope in space is called AstroSat. Heard of AstroSat? You can check it out in your internet, in Wikipedia. It is there for the last 8 years. And we have launched it to look at the universe. And you know how much of finding it has done? Till date, AstroSat finding has published 400 peer-reviewed journal publications. Based on the AstroSat finding, 36 people are taken PhDs. And the number of findings that AstroSat got in terms of finding new nebula, new black holes, new star explosions, and unknown places of space observation that it has made is really big. I think you must also learn that what we are doing in space-based telescopes. But it is not as big as the Hubble Space Telescopes or the Kepler or the ones James Webb. It is a small one. It is just a 2-ton satellite. But it has one of the finest instruments that anyone has put in space. The beauty of AstroSat is that it is able to look at space in multispectral means. That it can look at, in ultraviolet regime, it can look at in optical regime, it can look at X-rays, and such a beautiful instrument it is, suite of instruments it has got. And future we are going to build, what you mentioned, a satellite with similar to that. We have at least two programs to deploy deployable mirrors. We are planning to build a satellite called ExoWorld, which is a satellite to look at exosolar planets and find out whether it has life-sustaining features it has got, like water is available, temperature is comfortable, etc. For that, we are going to put a telescope in space also. Okay?
Sure, sir. Thank you.
Sure. Okay.
Thank you, sir. Sanjana K. Jai Gopal Garodia. Her question is non-technical but interesting. Please.
Yeah, Sanjana.
Namaste, Guruji.
Namaste.
My question for you is, what are the financial challenges faced by ISRO in ambitious missions like Chandrayaan 3 and Gaganyaan?
Financial challenges. Of course, we face financial challenges because asking more money is always difficult from government. You know, governments are always not very cash rich. There are a lot of programs we need to know. We need to build the roads, we need to give public health amenities, we need to build schools, we need to give education to people, healthcare, food, security. All of this takes a lot of money. You have any idea what is the budget, annual budget of India? How much money it is? Any idea?
I'm sorry, I'm not sure.
Tell some number. How many crores? Annual budget of India is how many crores?
50 crores about.
50 crores. Very good. Anybody has any objection to it? You can add them to few zeros also. Call it 5,000 crores. Okay? 50,000 crores? 1 lakh crore? Anybody, you can stop me. 10 lakh crores?
6 lakh crores.
Not enough. You have to increase further. I'll tell you, our defense budget alone is 3 lakh crores plus. Then you think about our other budget. Our agriculture budget is almost 1.5 lakh crores. Our that job for employment program itself annually it is 75,000 crores. So you can think of our budget. It is not a small budget. It is a huge budget. It could be as much as 35 lakh crores. It's a big money. And you know how much money ISRO gets annually? It is 12,000 crores. So you just imagine 35 lakh crore is the budget of India, and we get 12,000 crores, which is how many percentage? Anybody can calculate percentage? It's a very small percentage. So the money available for space program is very small, but it is good enough. I think we find it difficult to spend 12,000 crores many a times. So that is interesting part of it, because we are able to do things at extremely low cost. Now you build one big national highway, it takes more than this money, 12,000 crores, because every kilometer of road takes typically 5 to 6 crores of rupees to build 1 kilometer road, national highway of class. So you can understand the cost involved is very, very high in infrastructures. Space also is very costly. But that's why everybody praises ISRO for achieving all of this with such a low budget. So our goal is not to increase the money spending. I think that is not the measure at all. I don't want 1 lakh crore for space. I want only this much of money for space. But we will be able to do things with this much of money beautifully. What needs for the country, we should be able to do. But government is now very happy to give us more money. Last year, this year itself, government announced big programs for us. The Bharati Andhariksha Station is announced. Building the human spaceflight program extension is announced. New Chandrayaan program is announced. Orbital mission to Venus is announced. Taking almost the allocation of money to something like 30,000 crores plus for a 5-year program. And more money will come. So government is happy to give you money because India is no longer a poor country. You should remember that. Because that India has become a stronger nation, we are the 5th largest economy of the world. We should not be worried about spending little more money. And we are now reached a condition that we should be able to invest more in space. That is very clearly seen in the government's initiative to give more money to space program. So the challenges of having money is actually slowly going away because our businesses, our investments, our annual income from various sources in the country is actually increasing. You know, how much is the GST collection last month? You have any idea? You are paying to the government every purchase you make, everything you do, there is a GST. You know that? How much money comes out of GST every month? Any idea? 1.75 lakh crores is the every month tax collected. So India is a reasonably rich country today. Okay? Thank you.
Thank you, sir. I'm sure that you definitely feel a sense of pride on what India has been achieving. Aditya ML, Tapas student. Aditya.
Namaste, sir.
Namaste.
Sir, what are your views on many agencies trying to colonize the space?
Colonize space or moon or Mars? You are referring to moon or Mars or space?
Like in general, moon, Mars, even some asteroids.
Yeah, let them go. Why you are worried?
No.
I am not worried. Let them go. If you want to colonize Mars, you can go and also colonize Mars. You can go to moon and colonize. You can go to asteroid and colonize. You can go to Jupiter, Venus. Lot more planets available. Why don't you go and colonize? I think humanity should go and do it. It's important for us to go out and colonize. Because that's how there are human beings everywhere in the land available on Earth, except possibly Antarctica. Everywhere people are going, and even in Antarctica also there are Indians. You are aware of it? In Antarctica we have our own colony. Indian colony is available in Antarctica. We have our own station. ISRO also got a ground station in Antarctica. So soon we will also put up our station in moon. And we will also colonize moon. India will also be there. So all of us should go to space, other planets, possibly planets in other stars called exosolar planets, and find out one for India. When you grow up and become a scientist, I'll give you an assignment. You should find a good planet for India to colonize. Can you do?
I'll try my
You have to observe through the telescopes and find out what is the best planet India wants to colonize. So I don't have any worry about anyone going and colonizing. See, it's an effort that humanity has to do. Every nation will do. And we have to find out ways by which we can do it cooperatively, because every nation will find it difficult to invest a lot of money. So our effort today, scale up our skill and strength in space so that we can work with other big people and do jointly so that our cost will come down. You got it? Thank you.
Thank you, sir. Vivek Panchal from Tapas comes with an Indic perspective. Vivek Panchal.
Yes, Vivek.
Namaste, sir.
Namaste.
Sir, I want to know that what is the contribution of our ancient Indian astrology towards modern space researches?
Yeah, you use the word astrology.
Yes, sir.
I will use the word astronomy.
Yes, sir.
There is a small subtle difference between these two. In India, it was not different once. Astronomy and astrology were one and the same because they were done by the same people. So was the case in the Europeans when they started the whole program. Astronomy is more into the observation of the planets, stars, etc., finding out scientific explanation of its movement. And astrology, which we call the Phala Jyotisha, is another form of it, that based on that you can predict future of individuals and nations and many others. Yes. So astrology came as an offshoot of astronomy. So earlier observational astronomy and astrology are related. When the astrologers predict the positions of the stars and planets, it also follows actual positions. There is nothing wrong. Both are same. When they predict so lunar eclipse, it will occur only on the same day because the mathematics is same for both. Now coming to the question that you said, what was the input from the ancient astrology to the modern science? First thing I want to correct you, the ancient is a wrong usage.
Yes, sir.
We were not ancient. We were once the leading nation of finding astronomy and astrology. We were one of the leading nations. So it was the peak of knowledge in India, in Bharat at that point in time, and we were the only ones who actually deciphered how the universe is originated, how the planets and everything came about, their motion, planets' motion, star constellations, and many others were told. In which year? It was in 1600 BC we were able to tell all of this in books, in literatures. And later, many others came about, Aryabhatta, Varahamihira. Varahamihira is the one who started writing about the Phala Jyotisha, the effect of planet position on futures of individuals and nations. They started predicting that, and theories related to that came about, which later became the part of the Jyotisha or the Hora Shastra, which you talk about, the Phala Jyotisha. But then input to the modern science came from that only. Let us understand that the later knowledge about what we know about the universe, the sun, the solar system, the time scales, that's lunar and sun scales, that all of these are actually spheres, they are moving about, the Kepler's law which came about out of it, all came from that knowledge that existed at that time. So there is a link. Okay?
Yes.
Yeah, we must be aware of that link.
So,
yeah, thank you.
Thank you, sir. Sir, would you want a small break? We have another 25 questions to go. Ms. Chinmayi Agadi, Sadhana student. Chinmayi.
Yes,
Namaste, sir.
Namaste.
What is the benefit or practical use of finding elements and rich mineral resources on other planets, sir?
Okay, do you like gold? You don't like?
No, sir.
You have any ornament on your hand or anywhere?
Yes, sir.
Yes. But everyone likes gold. No? If you get a lot of gold, what will you do? Gold is very precious, right?
Yes, sir.
Why it is precious?
It is very costly.
It is costly because it is precious. Not that it is. If suppose it was plenty, like the sand here, will it be precious?
No, sir.
No. Is platinum precious?
Yes, sir.
Diamond precious?
Yes, sir.
Okay. Is uranium precious?
Yes, sir.
It is. It is costlier than all these precious metals I talked about. So every element has its own value. When it is not available in abundance, for example, the sand which is available in abundance has no great value other than for the purpose for which it is there. But there are precious materials like elements which itself. For example, helium-3. Helium-3 is a very precious material because you can generate energy out of it. You can also get many other precious materials from other planets. Suppose you are able to go there, mine it and bring it to Earth. It can be used very effectively, positively. You are aware of lithium? Lithium, you heard about lithium?
Yes, sir.
Lithium is used in our electric vehicles. Now all our batteries are made out of lithium. Lithium is very scarce on Earth. It is available only on 1 or 2 nations. Even India doesn't have a huge reserve of lithium. Recently there was some news that some lithium deposits have been found out. But mostly it is imported from many other nations. And we are importing so much of special high-end minerals for our use. For example, the stainless steel vessel you are eating food now, the stainless steel what you eat, it contains nickel, chromium, cobalt and many other very high-end elements which is mixed with the steel, mixed with iron. That is how you make the steel. But many of these are coming from outside. It is not mined enough in India. So we have a need of getting very precious elements from other places. If you bring it here, you can create more value. We can improve our life. We can bring out more materials which are technically useful, commercially useful, economically useful for us, or even for energy sometimes. For example, if you are able to extract minerals which are nuclear power sources, then all our energy needs will be fulfilled one day. So that is a statement that I know in helium-3 is available on moon. If you are able to mine helium-3 and bring it to Earth, every kilogram of helium-3 can generate energy for years together for a nation. It's stated, I don't know the science of it, but it is also possible. So going and mining minerals from other objects and planets is something that every space visionary thinks about, but technology is still not matured enough to bring it back to Earth at a cost-effective manner. That's one issue, which possibly in next maybe tens of years that will be solved. Okay? Thank you. Thank you. Thank you.
Thank you, sir. Students, I want to tell you that most of these insights you'll never find in the curriculum and the books. So make note of these things. It's interesting. Vivan Narain, Tapas student. Vivan Narain.
Namaste, sir.
Namaste.
Does ISRO have plans to use reusable rockets in near future, sir, like engines?
We already have. You have not seen the landing of the reusable launch vehicle at Chitradurga. You know, Chitradurga is here in Karnataka only. So we have a landing strip there. We did the landing trial of our reusable rocket 3 times successfully. So they are all winged reusable rockets. So we are going to make the next size, bigger one that will go to space and come back and land. But that landing will not be in Chitradurga, somewhere else we are planning. But then we are making another reusable rocket called the vertically landing reusable rocket. No, rockets go up vertically, the pencil-shaped rockets. It can come back and land on its legs. So for that we need new engines, which are throttling engines, methane engines. So we are developing them, and another 5-6 years we will have such a rocket. But you will see them in news maybe in 1 year that we have testing such rockets. So I am leaking out the news today. Okay? In 1 year we will be testing such rockets in India. Right.
Naresh, class 11 tapas. Naresh.
Namaste, sir.
Namaste.
What are the upcoming programs of ISRO which will create a benchmark in the field of space research? Like as you earlier mentioned about AstroSat and upcoming project TexoWorld, are there any other plans for ISRO to launch space telescopes and go further and explore our solar system beyond asteroid belt?
Yes, so many are there. So many are there. So one of the important announcements that the government has given recently is the announcement of Chandrayaan 4. You would have all read about it. Chandrayaan 4 is a mission to go to moon, land on the moon, collect samples from the moon, bring back to Earth. So this is a mission which is going to be very important mission called Chandrayaan 4. After that we are going to do Chandrayaan 5, which will go to land on the moon at the South Pole. We will have a big rover, 300 kilogram rover, going around the moon for almost 100 days, especially to the exact South Pole. We are going to go to Venus. A Venus mission is also announced. We will go and orbit the Venus and do study of the Venus. And recently government is taking action to approve a mission to go to Mars again. Last time we went to Mars orbiter mission was only an orbital mission. This time we will go and land on the Mars. Mars landing is very difficult because it has an atmosphere. So we will go and study that and Mars. We have an exo world that I already announced. Then we are going to build a space station called Bharatiya Antarisha Station starting in 2028, and it will be completed by building by 2035. And we will have future Chandrayaan series of mission which I cannot speak today. We will be, when it gets approval, we will be discussing all of that. And in 2040, we also made a plan to land our Indian on the moon. 2040, actual Indian landing on the moon will be by that time. So there are many missions of this nature. There are missions to study aeronomy called the space weather related studies. We have missions to study the exosolar planets I mentioned about it. We have studies to look at the sun, which is already knowing the Aditya L1. We also have future programs to look at it. So there are many such missions in the planning stage, in the pipeline, so which I can't announce all of them in this forum. Okay?
Thank you, sir.
Thank you, thank you.
So Namrata comes with a very tricky question. Class 11 sadhana. Namrata, please.
Yeah.
Namaste, sir.
Namaste.
Sir, my question is that how do you remain stress-free given the high profile, given in your high profile?
No, the secret is this, very simple. See, when you are in the position of the chairman ISRO, there are another 1,700 people ready to work for me, is it not?
Yes, sir.
The entire organization is there to work for me. And that itself makes me stress-free. Suppose all the responsibilities on me and individually I have to do, I will be very stressed. But when I have very capable hands ready to do the work for us, willing to spend their time and effort, ready to do the design, I can come here and talk to you. They will be working today. You understand?
Yes, sir.
So I am just coming from our control center. Just before here at 12 o'clock, I was in ISRO control center in Penia. Our docking is going to happen on 7th. Docking of the SpaceX satellites are going to happen. So they are preparing, they are controlling, their control center is, everybody is busy with a lot of programming, things like that going on. So I don't have to do anything. I have to only go and see everything is set, everything is planned, and it will actually happen on the day. So that's why I'm so relaxed and I'm speaking to you. So when you have very competent hands with you, knowledgeable people with you, you will be stress-free, correct?
Yes.
Only thing, you need to delegate the responsibility to them. Don't keep it with you. Make them responsible, make them own it, make them ensure that they are doing it. You only ensure that there are right people at the right place to do the things. then you will be stress-free. Correct? So that's a technique that you have to study when you grow up and become leaders in any place. Leaders do one, the most important thing is they delegate to people who are competent enough to do the task. Then you will be stress-free.
Thank you, sir.
Thank you. No, nothing.
Impana comes with a question of philosophy. Impana class 11 sadhana.
Namaste, sir.
Namaste.
To begin with, we Indians are not only stick to the Western science, but we do have faith on lot many things beyond the science. Now, my question to you goes like this. Being a man of science, how do you perceive the conflict between science and faith?
This question comes to me. This is because of a misunderstanding. That the word used something called faith, I don't have any faith. See, we science people don't believe. And this is not in the culture of Bharat, belief. We don't believe anything. We ask questions, We inquire. We try to find out. And this finding out is natural in science. It is very natural in philosophy of spirituality as well. Both are one and the same. And in the natural sciences, what you do, I don't know something, then I inquire it, I do experiments, I observe, then I hypothesize, I say this is the way it is, and if the hypothesis is true, we say it is science. Correct? This is how we do most of the physical sciences, and everything is found out like this. You hypothesize something which you are not aware about. Rishis did the same thing in the case of belief system you talked about. In Bharat, in our culture, there is never ever a talk about belief. You have to believe God. It is a concept that the Western thought process of spirituality brought into India. We don't believe in any God. We are experiencing God. We do not say that, yes, it exists. Your blindfold belief is not at all there in our system. There were questions about the birth, death, the spirituality, the God, everything in literature. You can see this. If you really go into our philosophy of belief system, so-called belief system, you will understand there is only questions and answers. And there is a courage of there are people in asking questions in our system. You can see that. And this is quite natural in science stream also. So I can tell you I am a scientist with a spiritual mind because both fulfill my requirements. One is to understand the external world. I ask the question of the science. To understand the questions of the internal world, I ask the questions still and satisfy my thirst for finding the spiritual answers. Both places I am inquiring and trying to find out. So there is absolutely no conflict. You understand?
Yes, sir.
So you do not get confused between the belief system of the others have introduced into your midst. This confusion is what is causing you to ask this question. You have to understand the fundamental nature of the teaching that we have created in this nation, in this country, is entirely different from what others have brought into this place. I am not telling one is better than the other or anything, but I am telling you the concept of spirituality doesn't conflict me because I am aware of this fundamental principle. Got it?
Dhanyavad, sir.
Dhanyavad.
Thank you, sir. Question gets interesting. Raksha Siddhappa Shirur, Sadhana class 11.
We have 30 more questions. 20, 25. No, depending upon your time. I am free.
You have time?
Yeah.
Sir, have time.
Okay.
Namaste, sir.
Namaste.
My question is, how can the research and technology developed by ISRO is benefited in the fields of agriculture, medicine, and disaster management?
I think you may not be aware today, all these areas, our space technology is currently being used. I'll start from the reverse direction, disaster management. The disaster management portal of India is made by ISRO. And this is operating in Ministry of Home Affairs today, called NDEM, National Disaster Management Framework, is actually built by ISRO, where any disaster that is happening in this country, let it be earthquake, heat wave, flood, or a cyclone, everything is mapped using our satellite data and other source of data and is presented to our Home Minister and in the department itself. And you can track it on a day-to-day, daily basis, which includes forest fires, it includes flooding, drought, pesticide activities, anything that you talk about. So we have at least 4 or 5 satellites which is actually monitoring disasters. All cyclones today are tracked by our satellites. Or floods that are happening, we track and then make predictions how it's going to increase or decrease and how the water level will increase in the coming days, and we give warning to the government for shifting people or anything like that. But of course, local floods possibly we will not be able to do. The bigger floods we do. Earthquake, of course, we cannot predict, but we can actually map what happens post-earthquake in terms of relief measures and many other things. So we work on that. Agriculture you mentioned, no? In agriculture, we have a big plan to work with the Agriculture Ministry. We have a center in Agriculture Ministry called Mahal Nobis Crop Forecasting Center. It's operating in Delhi. What it actually does is, based on our satellite data, every year we do the mapping of the entire country in all food seasons. You know, Kharif and Rabi seasons are there. So that seasons we map. We look at least 7 to 8 different crops, find out how much is the extent of cropping or the, that they have started the crops, and what is the growth rate. We give predictions to the government. And before the yielding happens, we actually estimate what is the yield going to be this year. And these estimates are given to the government. And based on that, the price fixation, the import-export decisions are taken for wheat, rice, rabi, jora, and many other wheat varieties. We also help the government in identifying what is a new land which is best for agriculture. And take, for example, horticultural crops. Recently, I came to know that northeastern states, at least around 30,000 acres of new land has been identified and cropping has started. Similarly, arid lands recovery, we do planning, we do in agriculture. There are so many different services in agriculture we do. We do in mineral mapping, we do help in mineral exploitation, and like that there are water resources planning, forest fire mapping. There is plenty of such applications which are running. We deal with the government ministries. ISRO doesn't talk about it because we are an enabler and provider of the data, and corresponding ministries do. For example, disaster is handled by Ministry of Home Affairs. Agriculture is handled by Ministry of Agriculture Department. Forest is handled by Forest Department, and we provide the data and create the framework and data utilization, the software, the framework, everything we give, and they operate. Okay?
And medicines.
Medicine, okay. In terms of medicine, of course, we cannot give you medical support. We have done earlier medical support that, telemedicine support we are given. No, we can actually do only satellite services. We can do communicate or observe the Earth. These are the only 2 things we can do. So, for example, medical time, we have done the telemedicine services to remote areas. Even now, most of our defense forces in the unreachable areas, we provide terminals for them to connect to the main hospitals and then get consultancy, medical care, etc. Similarly, we have done a lot of services in pest, for example, disease spreading studies, for example, vector-borne diseases, which are the vector-borne areas, identification, when there is some spread out of such diseases happen, what is the extent of spread. And we helped in case of COVID time also these type of studies, but not very, very large, but they are more of pilot level studies. Okay?
Dhanyavad.
Thank you.
Thank you, sir. Vachana, class 12, Rashtrotthana Banashankari.
Namaste, sir.
Namaste.
So my question is, what are the efforts made by ISRO to create awareness about space research and its significance?
Have you seen our ISRO's website?
Yes, sir.
You must see it today evening. Because there is a program coming up, or even X handle of ISRO. Just see today. There is an announcement how you people can get involved in learning about space through ISRO's website and classes that you are giving. The program is called Start 2025. It is for school students to register and learn from ISRO's classes which are available online for 1 month, free. Please register. You can learn various topics, and if you go to our website, you will find so many of materials which will be available to you. You can attend the classes online and get certificates also. Okay? Please try. www.isro.gov.in.
Yes, sir.
Okay.
If you hear very carefully, I think I've never come across a session as enriching because it's also a career guidance kind of session. We have Kiran Nayak, class 11, Tapas. Kiran Nayak, please.
Yes, Kiran.
Namaste ji. As the chairman of ISRO, you might have faced so many challenges.
Keep the mic closer. Keep the mic closer to your mouth. Yeah.
As the chairman of ISRO, you might have faced so many challenges. Can you share one such experience with how you used to manage that one?
So the only difficulty is that you will not understand the emotions behind those challenges. Even when I speak, you have to come to this seat and then face it. You understand? So whatever language I use to express your feeling, it will never be understood. You ask your mother, how do you feel that you are a mother? Can any mother explain it to you? You are impossible for you to explain. It is like same feeling when you become a project director of a rocket and see it taking its first flight. Can you imagine what will be the feeling of it? 10, 12 years you work in that rocket, from concept to on a paper, designing, developing, seeing its testing, and actually putting in rocket launch pad, and it takes off, and you stand there and clap. 12 years of your work, like a mother. I am not a mother, of course. But then experiences are to be actually experienced, cannot be shared by words. So I went through a lot of such extremely pleasurable events, as well as extremely not so pleasurable events in life while working on various things. So it won't be easy to share. So you can excuse me for that. And only advice I can give is come and join ISRO and experience it for yourself. No? Is it not good?
That's right.
Thank you.
Thank you, sir. Dhanush Gowda, Tapas, Class 11.
Namaste, sir.
Namaste.
Can you share some insights to prevent the brain drain of our youth seeking education in foreign universities and instead focus on more funding and opportunities here itself?
What are you worried that people are leaving India and going to other universities and Western world? Is that we are worried?
Yes, sir.
I am not worried about it.
Sir, like more intelligent people.
Who tell they are more intelligent than you?
They will go to MIT, sir. MITs and.
No, you are actually mistaken. Those who are going to MITs are not brilliant than you. They have some target to go to MIT, so they went to MIT. You don't have a target to go to MIT, so you are here only. That's all. Don't underestimate the people who are left behind. I am one who never went anywhere. I never went to a foreign university. The people available here in our normal schools and colleges who are not getting opportunity to get an IIT education are not inferior people at all. They are very brilliant people. I can tell you how good they are when I are working in ISRO. They are extremely talented people. Only thing they have not got an exposure, opportunity to see what is happening. That's all. Once they see that, they will also excel in life. There is no difficulty for it. You don't have to go to a Western country. Let 1 lakh people go from this country and go to other universities and get there. I am not worried about it. There is enough of people left behind. Is it not?
Yes, sir.
Every year, how many people go migration? Very small. We are, you know, what is the strength of India? Number of people here, 140 crore people. Out of that, 25% is youth. So that itself, you can count how many crores are there. And every year, we have fresh people coming in. There is no difficulty for us. Let them go. Okay, only thing which I want to tell you on the second part of the question is valid. Creating infrastructure in this country for having bright minds to work in this country. I fully agree with you. It is needed. In many sectors, it is needed. It is needed in science and engineering, medicine, and it takes than what is available today. Even now, we have a huge research capability in this.
Namaste, sir.
Namaste.
Firstly, I would like to congratulate our ISRO team for the immense success of both Chandrayaan 3 and Aditya 11. Sir, leading a premier institute at a global level is not a simple job. What made Dr. S. Somanath to reach the place where he is now, as well to take ISRO to global level? Kindly share your journey so far with us.
No, it's a very simple thing. Once you go to an organization which transforms ordinary people to extraordinary people, this will happen. Each one of you, if you come to ISRO and experience it, I can tell you, I was just an ordinary person, came from a normal background of a village, studied in a not an English medium school, but I had an opportunity to study very well, came and joined this organization and learned things from there and do things. So I owe all what I have achieved to the organization because they allowed me to grow in knowledge, in skills, in management, in developing systems to reach this position. That's how it happens. So it's not a special skill which I have. I think like me, there are thousands of people in my organization. You are only seeing me. But I can guarantee you that like me, there are other 1,000 people. That's why the organization is running very well. So everyone in ISRO is very proud of what they are doing there. Because we have a mentorship inside. Those who joined there are mentored by my seniors. They are taught. We don't have a teaching class course within ISRO. Those who joined there learn in work. And we learn based on our interest and skill and appetite that we are able to learn. See, after joining my graduation, I took my master's, I took my PhD while I was doing work in ISRO. And I was allowed to do all of this and improve my skill and knowledge and contribute to the organization. So primarily the growth is a result of the assignments that the organization gave me. They spotted the talent in me and put it at appropriate level so that I can handle higher levels of responsibility. So we mentor a lot of people. Today, as a chairman, I mentor a lot of people. I watch at least 300 people in my organization personally and look at them, what the jobs they are giving, what assignments they are given, how they are placed there, so that tomorrow new chairman will come out of it. New leaders will come out of it. So we do this on a continuous basis within the organization to create next layers of leadership. I believe it is done by many, many organizations all across the country. That's why we have a success in this organization. Whichever organization does this will definitely succeed.
Sir, am I supposed to add something?
Yeah, please.
Sir, still up to now we talked that other countries along with India are working to get into outer space. But what if all we unify? Why are we not planning for it?
I will ask you, why we are different nations? Why don't we all come together and become one nation of the entire world? Will it happen?
No, sir.
Why it is not going to happen?
Sir, because the origin or the culture or the belief what we have are different.
So there is a concept of a nation which is demarcated by the people and the boundary and the culture it represents. It has a unique identity, right? So this is true in every sector, every nature of our work. Though we may allow certain levels of cooperation in many areas, but each one has its own identity. And it is true in space, it is true in every domains of work that we are going to do. Of course, we need to cooperate for a common cause. For example, when there is a pandemic, we need to cooperate to save humanity. Suppose an asteroid is going to come and destroy Earth forever, like what many years it happened, no? Many times Earth has been hit and destroyed. If it is going to hit, all of us will come together and then fight against it and destroy the asteroid so that it won't hit Earth. Otherwise, we will separate out and fight each other. This is natural process of human society. So we need to keep identity, but we also need to find out ways by which we can cooperate. It's the reality of life.
Dhanyavad.
Thank you. Two very important insights from that. How do you complete the phrase Vidya Dadati? Vinayam. You see humility in person. Second thing, sir spoke about the organization transforming you. We want you to experience Rashtrotthana helping you transform and bringing you to a different culture. That's exactly what the essence of sir's talk. Lalit M, class 9, Rashtrotthana Banashankari.
Yes.
Namaste, sir.
Namaste.
My question is, what strategies has ISRO adopted to encourage young minds to pursue careers in space science and technology?
Of course, that's a job that cannot be done by ISRO alone. It is the job that is to be done by the government in terms of teaching, in terms of creating the infrastructure to young people to come. But as an organization, ISRO, what I can do is we engage with young people like you wherever it is possible. We go to schools and colleges in our centers where we are working, like in times like the Space Week and other celebration time. We bring them to the institutions and then show them this is how the ISRO is and inspire them to talk about it. We conduct online classes to make you interested in it. Such things we can do. But the reach is very limited. You should understand that an organization like us cannot reach to the entire country where the demand for reaching to is much, much bigger. So that's why we tie up with a lot of NGOs. For example, VIPA does a lot of work with us in terms of taking our exhibition centers to far-flung places of the country. There have been entire northeastern states, and northern India has been covered recently using our ISRO's space on wheels buses. We have 6 such wheels, space on wheels buses. We go around the entire country and spend the message of space and technology to them. So such activities we do. But beyond that, we cooperate with all the NGOs in spreading the message of space, science and technology. Thank you.
Thank you, sir. Imagine a classroom being like this. It's an amazing lesson for us teachers also. Ajay Vakuda, 9th standard, Rashtrotthana Banashankari.
Namaste, sir.
Namaste.
Congratulations on your recent SpaceX mission launch. My question is, how does ISRO plan to work with fields like quantum computing and biotechnology to speed up the space technology development?
Both I mentioned just now that quantum we are already working on. We are not into quantum computing because that skill still do not have in ISRO. But there are some other organizations in India that is working on quantum computing. There is something called Quantum Mission, which is announced by government. In that Quantum Mission program, ISRO is also a stakeholder. We are also part of that Quantum Mission program, in which quantum communication has been taken by ISRO. We already got a funding to the tune of almost 800 crores to develop the quantum communication infrastructure. And we have already demonstrated quantum communication architecture through space. So we were able to encrypt using quantum key distribution, and we are now going to launch it to space also. 2 satellites will be built and launched to demonstrate that capability. So this is what we do in quantum. And the next you asked is about biotechnology. Okay, there is last month we have signed a agreement with the Department of Biotechnology, we call DBT, on finding space and biotechnology to join together to work on new areas. So this will be primarily on doing biotechnology-based research in microgravity environment like space station and PSLV, orbital platform. So today you can look at our Twitter handle and find out seeds germinating in space. One photograph is already put in the Twitter. We have done a biological experiment. The first time life grows in space. You can see that in website. We also have 3 other experiments going on. One on a gut bacteria experiment, and another is on spinach. 2 more experiments are happening in space today. So we are going to work on biotechnology, medical research, that area slowly into it, and we are trying to find out with some of the labs the Department of Biotechnology has find cooperative ways of doing it in space. Already started.
Dhanyavad, sir.
Thank you.
Lakshmi Ananya, standard 8th, Rashtrotthana Thanisandra.
Namaste, sir.
Namaste.
My question is that what safety measures were adopted for the satellite Aditya L1 to mitigate the damages caused by the sun?
Suns won't damage that easily because there are radiation from sun, there are particle emissions from sun. So damages can happen to electronics especially and materials in satellite. So what you do is to prevent it, we buy electronics which are called space grade. It's not the one mobile phone. If you take mobile phones to space, it will die. It will not work in space. Within no time, it will become non-functional because the electronics which inside the mobile phones are not space qualified. We call space radiation hardening. The space has a very high radiation. And once it is exposed to radiation, the electronics will stop functioning. So in ground vehicle work, because the earth protects, the atmosphere protects all of this. So, and then there is another damage due to radiation, cosmic elements. All materials like the aluminum, steel, paints, everything will get damaged over a period of time. So we have to design it for a certain life. So use special materials and special life care system, etc., to make sure it has a sufficiently long life, not to cause any damage. So it is there in the design. Okay?
Thank you.
Thank you.
All good things must come to an end. We have 4 more questions. Mohit KB, standard 10th, Rashtrotthana Davangere.
Namaste, Guruji.
Namaste.
Guruji, my question is that
how can or how will ISRO be able to leverage AI in its future missions?
I'll tell you, there are a lot of things that I explained in one question what all areas in AI we are doing. I'll give you an example. We recently designed a humanoid, Vyomitra. Have you seen it in some media talking about?
No, Guruji.
No, okay. You can search Vyomitra and you will find out some article on it. And we built that Vyomitra to do certain tasks. Suppose you tell the Vyomitra, go and touch, switch on the light, it will go and switch on the light. Do this mission, speak about like this. So you can give in language, natural languages, you can speak to it and it will do some function. So we are going to put in our Gaganyaan. So we made it ready and we were in the laboratory when our Honorable Prime Minister Modi ji visited us. He came to review the Gaganyaan program. So we displayed it there. There were 10 questions. All questions were written in Hindi. And if you speak to the Vyomitra in Hindi, it will do the task. So Modi ji got so excited about it, he started asking this Vyomitra to do these tasks. But he was so intelligent, he didn't go 1 to 10. He thought that if you say 1 to 10, it would be already programmed to do that in that sequence. So he asked from 8 first, second last. But then we were all very worried whether this Vyomitra will do the function very correctly, because the accent of the Hindi of the Prime Minister is slightly different than, it is not the, sometimes the machine doesn't understand. But we are programmed in AI in such a way that it understood exactly what he said and did all the 10 he commanded the Vyomitra to do. And finally he is, Modi ji, he will not be that easily satisfied. But then at the end of it he said, very good, he said. So that itself was a great certificate for our AI people in ISRO. So you understand the natural language processing. Using our normal communication languages, whether you are able to do computation and do certain tasks, it becomes very important. This is one of the AI applications. There are plenty of AI coming. I mentioned about the image processing, object identification from space, fault detection and isolation. You find when Gaganyatris are traveling, suppose there is a issue in the rocket, how to identify before it manifests in terms of explosion, how to save the crew. We are going to use AI. We are also going to use AI to identify defects in materials and manufacturing processes. There are plenty of AI usages going to happen in the coming days. Even design of the rocket one day will be done by AI directly. Okay.
Thank you, sir.
Thank you.
Thank you. The next question somewhere goes there. Swayam Hiremat, Class 11, Rashtrotthana, Dharwad. Swayam Hiremat.
Namaste, sir.
Namaste.
My question is, what are ISRO's plan for developing a fully cryogenic rocket?
Fully cryogenic rocket, we don't have a plan. The reason is simple. Fully cryogenic rocket is not economical. Reason is this cryogenics, you are using hydrogen and oxygen as the fuel and oxidizer. Hydrogen is a very light fuel. Even if you compress, convert into liquid, its density is 1/10 of water. So if you store hydrogen in tanks, you need huge tanks. The rocket size will become massive. Though the engine is very efficient, the tankages which has to carry the hydrogen will become massive. The rocket will become prohibitively bigger. So the right approach in a rocket design is to use semi-cryogenics in the lower stages and cryogenic for upper stages. So that in semi-cryogenics we are using the fuel called kerosene, which has a density very, very close to water, not up to the water. So you need a smaller tank. But the efficiency is slightly lower than cryogenics, but still it is very good. So the world over, the approach is you go for semi-cryogenics for most of the part of the rocket, except the last part of it, which will be cryogenic. So we will use that approach only, which will be more economical and which will result in a much more compact rocket. Maybe when you grow up and study a little more engineering, you will understand what I mentioned. Today you wouldn't have got it, but take it from me that this is true. Okay? Yes. Thank you.
Dhanyavad, sir.
Thank you, sir. The last but one question. Daritri, Class 9, Rashtrotthana, Hagaribommanahalli.
Namaste, sir.
Namaste.
My question is, what is the dream discovery you want to achieve?
My dream? My dream is very simple. India should be a country where everyone will aspire. It is something that we are marching towards, no? By incremental steps we are marching towards. It is by creating sufficient wealth, it is by creating advancement of technology, and it is by creating leadership in many, many domains that we will reach that. And while doing all of this, we should also make sure that we don't cause damage to others. We consider the concept of Vasudhaiva Kudumbakam as a principle on which that we'll work. We'll find out the universal nature of human beings and everything. We'll turn out by looking at the Bharatiya, our belief system, or whatever you use the word Bharatiya system, to be transmitted all across the world so that everybody adapts this. Now, all of these are part of this great vision. Do you see that as a merit?
Yes, sir.
Will you take it as your dream?
Yes, sir.
Yeah, all of you, will you take that as your dream? That's it. Thank you.
Thank you, sir. The last question from, you had to add? Are you, sorry, ask.
Sir, sorry to interrupt. I can't control my ego to discuss with you, sir. Please attend my question.
I couldn't hear you.
Please hold the mic closer.
Sir, why the scientists are failed to teleport the people? It means quantum analytics. If it is developed after many years, can the people will teleport this Earth to other planets?
I do not know the answer. If I know all the answers, then I will be something different. No? Teleportation is a concept that you will be able to transmit all of us in the form of energy and then convert the energy into physical form somewhere else. Then only it is possible. You cannot go in physical form in teleportation. It need to be converted into energy or quanta and then reassemble it in the form of physical form. Till now, we have not found out that to do for bodies like us. Possibly some materials can be teleported. Some elements, some atoms can be teleported, possibly. That you can recreate it somewhere else. But complex molecules, I don't know how to do that. Till now, the technology has not come out. Possibly, you will all do research and find out a little later. Until then, we will wait.
Sir, but one scientist was already conducted that experiment and succeeded in that.
Yeah, all of these experiments are done in some elemental level, very small level. And when they teleport one electron from here and get the electron at the other end, or take an atom from here and take the atom, reassemble the atom somewhere end, they call it teleportation. But it is not a complete object by itself. It has not been achieved so far. Thank you.
Thank you, thank you. The last question from the student for the day, Shreyas, 9th standard, Rashtrotthana Tanisandra. Shreyas.
Namaste, Guruji.
Namaste.
My question is that how do you simulate zero gravity or deep space conditions on Earth to test spacecraft and equipment?
It's very easy to simulate zero gravity on Earth. Anything falling is in zero gravity. On your, it's not a mango tree. What type of tree is it? I don't have a fruit here. If the fruit is falling from that until it touches the surface, it is in zero gravity. Do you know that?
Yes, sir.
Can you believe it is so?
No.
That's what very difficult to believe. Everything that is falling is in zero gravity. If you sit on the mango that is falling, suppose you had an opportunity to sit on that particular mango while it was falling, it is actually on a zero gravity. If you jump from there and then before you reach here, you are in zero gravity. But when the moment you reach and touch the surface, gravity comes. So if you have to do contact experiments in zero gravity on Earth, the technique is called drop towers. We make long towers, something like 100-meter tall towers. Tower built, and inside you will make it vacuum. You remove all the air. So it will become space. From the top, you can drop scientific experiments. So it takes some 1 or 2 few seconds to reach the bottom. In that dropping time, you can conduct experiments.
Dhanyavad, sir.
Another technique is there in aircraft. There is something called loops they take. Aircraft can fly like this. It will climb like this and reach here, and then it will do a nose dive. During the nose dive, you would have seen people floating in the aircrafts. In movies, you would have seen. So all this happens during these nose dives. So it is similar to the free fall conditions. So if you can simulate a free fall of aircraft, also you can create zero gravity.
Dhanyavad, sir.
Okay, thank you.
Thank you, sir. I must admit the questions never end, but the time is always a constraint. With due apologies to some teachers who have presented the question, we end this session now with a profound thanks and gratitude to Somanath sir for having been here. Let me just end with this small phrase. Students, when you read stories and inspirations of great people, there is this moment, there's this experience, there's this meeting, there's this theory, they come across and experience inspiration. Perhaps today was a time like this, an event like this. I'm sure many of you have drawn a great amount of inspiration apart from the words, apart from the thought, apart from the life. The very fact that for 90 minutes, for in a breathless manner, Sir could continue on everything that you had a question on, that itself stands out as a testimony to his commitment to whatever he does. It's been a great event. Thank you very much and an honor. Thank you, Dhanyavad.